Okay, so welcome. This is question 4 for the Edexcel C3 hard paper. This is the G4 paper. Okay, as I said, it's, the link's in the description, but if it's not, then go on to physicsandmathstutor.com and you look in the A-level maths papers, and it's Edexcel bronze, silver and gold, and G4 paper. Okay, as I've specified before. So what I have to find here is the gradient of this curve, the equation of the tangent of this curve, x equals cos of 2y plus pi, at x equals 0 and y equals 4, or the coordinates 0, pi and 4. Okay, so the first thing we need to do, obviously we've got our x and y are, we need to find the gradient. Now the gradient is often obviously referred to as dy dx, but that says differentiate the y equation with respect to x. Well, we've only got the x equation here, so the only thing we can do is dx dy, find out what that is, and then do 1 over that. Okay, so dx dy. Well, obviously you have to remember pi is a constant, so it's just when you differentiate cos you get negative sign. Okay, so it's negative 2 sine 2y plus pi. Okay, so that is your answer. But remember, that is the gradient. Well, it's not technically your answer, it's the gradient function. Okay, it's not your end answer. Okay, and because we know y is pi and 4, we sub y to be, we want dy, I'm going from this. As I said, it doesn't matter which way around you do it. As long as you do 1 over the end answer. Right? So, dy dx is 1 over this. Okay, so 1 over negative 2 sine 2y plus pi. But as we know, 2y is pi on 4. So if we times that by 2, we get pi on 2. So it's 2 sine pi on 2 plus pi, okay? Which is obviously 2 sine 3 pi on 2, or 1.5 pi, obviously. And obviously that leads you to 2. Okay, so it's dy dx is a half, 1 over 2. 1 over 2. Okay, so that is your gradient. Now you know your x coordinate is 0, your y coordinate is pi and 4. So all we do now is just do y take y1 is equal to m brackets x take x1, sub in what we know. Okay, so say y1 is pi and 4. It's equal to gradient, which is a half, brackets x take x1. Now x1 being 0, you can just x take 0. Alright, okay. Still need to write it in. Now, what we can do here is we want it in the form y equals a plus bx, okay? Or ax plus b, sorry. So, we're not going to times it all by 2, or times it all by 4, because it wants it just in terms of y. Well, y in terms of just x, sorry. So, we don't want any of this fancy, normally what we do is times it all by 4, but as I said, you just want it in the form y equals x on 2 plus pi on 4. Okay, so that is your end answer. Because obviously if you expand that, you just get x on 2, and you move pi on 4 over to the right hand side. Okay, so that's a very, very easy question. I don't think really should have deserved to be in this hardest paper, because it certainly wasn't the hardest question. Okay, so it's just a simple case of rearranging and being able to realise 1 over dx dy is the same as doing dy dx. Okay, and then subbing it in as a standard C1 equation of a line. Okay, and the key thing with this is remembering it was the tangent, okay, which has the same gradient as the curve, so we don't need to do anything with that once we've found the gradient of the curve at that point. Okay, and that was worth a whole 6 marks as well. So as I said, it's quite an easy question, and most of you hopefully should have been able to get that. Okay, so thanks for watching, and we'll see you in question 5.